Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations with variable coefficients. So let's get going. Problem: solve x square d square plus 2xd minus 20 into y equals to x plus log x. Solution. So we are given a differential equation with variable coefficients. Now we are going to reduce this to a differential equation with constant coefficients by making some substitution. And also we are given a Cauchy's equation. Given Cauchy's equation x square d square plus 2xd minus 20 into y equal to x plus log x. Now let's make the substitution. Put x equals to e power z, then log x to the base equals to z for x greater than 0. Let theta equals to d by dz. Here theta is a differential operator with independent variable z. And xd equals to theta. X square d square equals to theta of theta minus 1. Right? Now the above equation becomes theta of theta minus 1 plus 2 theta minus 20 into y equal to, replace x by e power z and log x by z. Then theta square minus theta plus 2 theta minus 20 into y equal to e power z plus z. Then theta square minus theta plus 2 theta is plus theta minus 20 into y equal to e power z plus z, which is a linear differential equation or higher order linear differential equation with constant coefficients, right? And also this is in operator form, f of theta into y equals to some function of z, which is in operator form f of theta into y equals to q of z, where f of theta equal to theta square plus theta minus 20. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Now we need to find yc and yp. Firstly, we will find yc using the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equals to, we have f of theta, theta square plus theta minus 20, right? Let's replace differential operator by m, so that we'll get f of m equals to m square plus m minus 20. Then our auxiliary equation becomes m square plus m minus 20 equal to 0. Then m square, we can write plus m as plus 5m minus 4m minus 20 equals to 0. Now take m common from the first two terms, we'll get m times m plus 5. Now take minus 4 common from the next two terms, we'll get minus 4 times m plus 5. Right? Then m plus 5 exists in both the terms, so let's take m plus 5 common, we'll get m plus 5 into m minus 4 equal to 0. Now equate each factor to 0. From m plus 5 equals to 0, we'll get 1 root, and from m minus 4 equals to 0, we'll get 1 root. So m equals to minus 5 plus 4 are the roots of our auxiliary equation. Therefore, the roots are real and distinct. We know that when two roots are real and distinct, say m1 and m2 are real and distinct, then yc looks like c1 into e power 1 root into z plus c2 e power another root into z, right? Now coming to our complementary function. Yc equals to c1 e power minus 5 into z plus c2 e power 4 into z. Then yc becomes c1 e power minus 5z plus c2 e power 4z. Now we are having yc in terms of z and we need to write in terms of x. For that purpose, we'll replace e power z by x and z by log x. But here we have only e power minus 5z and e power 4z, right? So we can replace e power z by x. So before replacing e power z by x, we'll write e power minus 5z as e power z whole power minus 5 plus c2 into e power 4z can be written as e power z whole power 4. Now it's easy to replace e power z by x. Then we'll get c1 x power minus 5 plus c2 x power 4, right? Since we know that x power minus n is 1 by x power n, then we can write x power minus 5 as 1 by x power 5, right? Then this becomes c1 by x power 5 plus c2 x power 4. So we got yc now. Let's find yp. Particular integral. We'll find yp using 1 by f of theta into q of z. This is equals to 1 by f of theta. We have theta square plus theta minus 20 and q of z is e power z plus z. We can write this as 1 by theta square plus theta minus 20 into e power z plus 1 by f of theta, theta square plus theta minus 20 into z. Now we can find each term separately for our convenience. First one, 1 by f of theta into e power z. So this is of 1 by f of theta into e power az form, right? For a equals to 1. And also we have f of theta equals to theta square plus theta minus 20. For a equals to 1, find f of a, which is equals to f of 1. Always remember that the denominator must be non-zero. If the denominator becomes 0, we'll get 1 by 0 into e power z. Since 1 by 0 is undefined, so total term becomes undefined. Okay, fine. Now let's find f of 1. This is equals to 1 square plus 1 minus 20. Equals to 1 plus 1 minus 20 is 2 minus 20 is minus 18, which is non-zero. Since by replacing theta by 1, we got the denominator non-zero. Since f of 1 is non-zero, so we can replace theta by 1 in the denominator. We'll get 1 square plus 1 minus 20 into e power z. This is equals to 1 by 1 plus 1 minus 20 into e power z. This is equals to 1 by 2 minus 20 into e power z, which is equals to 1 by minus 18 into e power z. We can write 1 by minus 18 as minus 1 by 18 into e power z, right? Since we have, okay, let it be. So this is the result obtained from the first term. Now coming to the second one. Or we can write in terms of x here itself. Okay, just replace e power z by x, then we'll get minus of 1 by 18 into x. Okay, since e power z equals to x. So the result obtained from the first one is minus 1 by 18x. Now coming to the second one, this is 1 by f of theta into z per k form. So here we are having the lowest degree term minus 20 in the denominator. So let's take minus 20 common from all the terms, right? But for the first two terms we don't have minus 20. So let's multiply and divide minus 20 to the first two terms for our convenience, so that it will be easy to take common. Okay, and we'll write minus 20 as plus of minus 20 into z. Now take minus 20 common from these two terms, we'll get 1 by minus 20 into theta square plus theta by minus 20 plus 1 into z. Okay, now we can write this as 1 by minus 20 into, we can write this as minus theta square plus theta by 20 plus 1 into z, right? This is equals to 1 by minus 20 into, we can write this as 1 minus of theta square plus theta by 20 into z. Now split the fraction. We can split the fraction as 1 by minus 20 into 1 by 1 minus theta square plus theta by 20 into z. Now this becomes, we can write 1 by minus 20 as minus 1 by 20 into, we can write this fraction as, see this is of 1 by 1 minus x form, so we can write it as 1 minus x whole inverse, right? So we can write this as 1 minus of theta square plus theta by 20 whole inverse into z. Now we are going to use binomial series expansion to expand this. So before expanding 1 minus theta square plus theta by 20 whole inverse, we'll find derivatives of z. Theta of z is 1, right? Then theta square of z is, theta square of z can be written as theta of z. We have the value of theta of z which is 1. Then derivative of 1 with respect to z is 0, right? Likewise theta cube of z is 0 and so on in general. Theta power k of z equals to 0 for k equal to 2, 3 and so on. Right? Now coming to the expansion of this. So we are going to use 1 minus x whole inverse, which is equals to 1 plus x square plus so on. Now let's expand 1 minus theta square plus theta by 20 whole inverse. For x equals to theta square plus theta by 20, we'll get 1 plus theta square plus theta by 20 plus theta square plus theta by 20 whole square plus so on, right? This is equals to 1 plus 1 by 20 into theta square plus theta plus 1 by 20 square into expansion of theta square plus theta whole square is theta square whole square plus theta square plus 2 into theta square into theta, right? This is equals to theta power 4 plus theta square plus 2 into theta power 2 plus 1, 3. So we know that a power m whole power n equals to a power m into n. From that we got theta square whole square is theta power 4, right? Now write the expansion of theta square plus theta whole square, theta power 4 plus theta square plus 2 theta cube plus so on. So here we notice that from the second term, or in the second term, we are having theta power 4, theta power square, theta power cube, right? So these are higher derivatives, so we can neglect all the higher derivatives from here. or all the terms from here, and also theta square from the second term, because we have theta power k of z equals to 0 for k equals to 2, 3 and so on, right? So we have only one value for z, that is for theta. Now coming to second one, this becomes minus 1 by 20 into expansion of 1 minus x whole inverse is 1 plus theta square plus theta by 20 plus theta square plus theta by 20 whole square plus so on into z, right? This is equals to minus 1 by 20 into expansion of 1 plus all this 1 plus 1 by 20 into theta square plus theta plus 1 by 20 square into expansion of theta square plus theta whole square is theta power 4 plus theta square plus 2 theta cube plus so on, right? Plus so on into z, right? Since theta power k of z equals to 0 for k equals to 2, 3 and so on, and so neglect higher derivatives from theta square, theta cube and so on, right? So we can neglect all the terms from here, and also we can neglect theta square from the second term. Then this term becomes minus 1 by 20 into 1 plus 1 by 20 into theta into z, right? This is equals to minus 1 by 20 into 1 into z plus 1 by 20 into theta of z. Now we have the value for theta of z, which is 1. Let's replace, or let's put the value here. We'll get 1 by 20 into 1, which is equals to minus 1 by 20 into z plus 1 by 20. So this becomes minus 1 by 20 into, take the LCM here, we'll get 20 in the denominator, and then in the numerator you'll get 20z plus 1, right? This is equals to minus 1 by 20 into, we can split this as 1 by 20 into 20z plus 1. So this is equals to minus 1 into 1 is minus 1 by 20 into 20 is 400 of 20z plus 1. Or you can write this as minus of 1 by 400 into 20z plus 1. Since we are having second term in terms of z, we need to write in terms of x. So we'll replace this z by log x. Then this becomes minus 1 by 400 into 20 log x plus 1. Okay. So therefore, the result obtained from the second term is minus of 1 by 400 into 20 log x plus 1. Now coming to yp. Now yp becomes, result obtained from the first term is minus of 1 by 18 x, and result obtained from the second term is minus of 1 by 400 into 20 log x plus 1. This is a required yp, and also we got yc. Now let's write the general solution. The general solution is given by y equal to yc plus yp, right? Then y equal to yc, we have c1 by x power 5 plus c to x power 4 and yp is minus of 1 by 18 into x minus of 1 by 400 into 20 log x plus 1. So this completes the problem. So we have seen a problem from higher order linear differential equation with variable coefficients in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.